All right, guys. All right, guys. So this is the last question about Hayden building a rocket for science fairs. Mr. Roger blasting poor animals into outer space. This one doesn't have a parachute to come back, so bye-bye. But we're looking at another classic piecewise function, and we're going to go ahead and number those parts: section 1, section 2, and section 3. We have to identify each of the general rules. So section 1, we can see they gave us a hint right up here. For section 1, we're looking here at a quadratic, y is equal to ax squared. For section number 2, we're looking at the constant function where y is going to be equal to some number. And then section number 3 is a linear function. It's a straight line. And look what they did. They gave us the whole equation. So write it down. Y is equal to negative 2.25x plus 66.25. So not a ton to find on this one. The bigger thing, though, is the question itself. And you'll see here they're asking us by how much time did the rocket spend at or above 20 meters in height. So before I run into the rest of my algorithm here, we'll stop for a second and just remember what this actually means. The question says, where on the graph is the kitten above 20 meters? Well, the kitten's at 20 meters right here, at that spot. And you can see the kitten is traveling now above 20, right? So below 20, take off, getting higher, getting higher, getting higher. At 20, now above 20, above 20, above 20, above 20, and then the kitten stops descending. It stays at that height for a while. I guess the rocket flattens out and flies horizontally for a while. And then at this point, starts to descend. And right over here is the second point, I guess, at which the rocket, anyways, if not the kitten in it, starts to descend and hits 80 again. So there are two places where, 20 again. There are two places where the y is equal to 20. Here's the first place where the y is 20 and the x is unknown. And here's the second place where the y is 20 and the x is unknown. And so those two places are what we're interested in. And they want to know the difference in the x's. They want to know like how much time elapsed between these two spots. Well, if you take that x and you take that x and you get the difference between them, which is a subtraction, you'll have the answer to the question. So really, this last question always works the same way. They'll give you a y, you have to get the two x's using the two rules that are involved, and then subtract. So back to my algorithm. We know that that first function is quadratic. We know the second function is a constant. We know the third function is linear. Specific rule was given to us here. We need the specific rule here. We're going to need the specific rule here if we're going to go anywhere. And we've got some critical points up here at the top corner are going to be very important to us. We know that the x value over here is a 10 because the first function ends where the x is 10. And we know that the second function ends where the x is 15. Yeah. And we don't know the y's just yet, but look what they did. They gave us that rule right over there. Y is equal to 32.5. So a ton here has been given to us. We've got critical points are answered. We're able to do a whole pile of work here. So the only thing we really need to find to start before we can kind of get into this part here is the rule. And to do that rule, we need to get the a. And in order to do the a, we need a point. We don't have everything here, so we can't use it, but we have that up there because of this information over here. So there's your x, there's your y. 32.5 is equal to a times 10 squared. 32.5 is equal to 100a. 10 squared is 100. Trust me on that. You can check it on your calculator if you want. Now we have to divide by 100, and when we do that, 32.5 divided by 100, you're going to get 0.325 is equal to the a. So the first rule is y is equal to 0.325 x squared. 0.325 x squared. So everything is complete in terms of the graph itself now. We have all the information. So now comes the interesting part. It's the question about the 20s for the y. So the first time the y hits a 20, the first time right over here is with function number 1. So for function number 1, we know that the y is a 20. So 20 is equal to 0.325x squared. We know that the y is a 20, and we're looking for the x. I'm going to put that on hold for a quick second. The second time the function hits a y of 20 is over here on the right, on function number 3. On function number 3, the y hits a 20, and we're looking for that x. So 20 is equal to negative 2.25x plus 66.25. Quadratic function, linear function. Quadratic function, linear function. And we're looking for the x's when we know the y's. That's it, straight up substitution. So I have to solve here. I'm going to solve by dividing by 0.325. So 20, bring up my calculator now. Sorry. I hope the glare is not too bad. Give me a minute. All right, there we go. I'll just clear that. So 20 divided by 0.325. 20 divided by 0.325 is equal to that crazy number, 61.5384, whatever. I'll put 61.54, let's say, is equal to x squared. And I got to get rid of that squared, so you're going to take the square root of both of those numbers. I'll leave the whole thing in my calculator so I can get a better or a more accurate answer, and I'll just come and grab the square root, and I get 7.84. So one decimal place for seconds is enough for this, so I did tell you to round it to the nearest tenth, so 7.8 is your first x. 7.8 goes right there. So the first time the kitten hits 20, or the rocket, the y hits 20, the x is 7.8. Function number 3 now, to catch the 20 on the other side. Same deal, except we're solving with the linear function, so I'm going to subtract the 66.25, and then I'm going to divide by the a in order to get the x. So 20 minus 66.25. 20 minus 66.25 is going to be equal to negative 46.25 is equal to negative 2.25x. So I just subtracted that from both sides, and now I have to do the division to get rid of that multiplication of that on both sides. So I'll take that number and divide it by that number, divided by 2.25 negative, don't forget the negative, and that's equal to 20.55, rounded to one decimal place, 20.6. So that's 20.6 right there. So the first time is at 7.8. The second time is at 20.6. Sorry, 7.8 for the first time, 20.6 for the second time. And now what do? We subtract those two numbers, 20.6 minus 7.8, and we get 12.8. Done. Good luck on the test, guys. Don't forget the algorithm. Don't forget to write down your steps on your memory aid. Don't forget about those critical points and making sure you're using the information you're given, your general rules. And if you do this again, this practice sheet again, it should result in a good score. Good luck.